Hi, this is javinkharod, a chemical engineer by profession, going to continue our today's topic, control valve. Now, what is that? A control valve is a valve used to control flow verifying size of the flow passage as directed signal from controller. Enable the direct control of flow rate and consequential control the process quantity such as pressure, temperature, and liquid level. Automatic control terminology, control valve, term final control element. Air actuated control valve, each with 420 megaampere I to P converter integral to a valve positioner. In this example, each positioner is comparing the valve stem travel against control signal and applying any correction. Opening and closing of the automatic control valve, usually done by electrical, hydraulic, and pneumatic actuator. Normally, molding valve, which can set any position between fully open and fully closed. Valve positioners are used to ensure the valve attain the desired degree of opening. Air actuated valves are commonly used because of their simplicity. The only required compressed air supply, where electrically operated valves require additional cabling and switch gear. Hydraulically actuated valve required higher pressure supply, return line from the hydraulic fluid. Pneumatic control signals are traditionally pressure range 3 to 50 psi, zero point 0.2 to 1 bar, and more commonly now electric signal 4 to 20 megaampere for industries 0 to 10 volt or HVAC system. Electric control now often include a smart communication signal comprise a control current. Such health and verification of valve position can signal back to the controller. The Heart Fabulous Foundation Profinet Profibus, the most common protocol. Automatic control valve consists three main parts, exists several type and design. Valve actuator, which move large valve molding elements such as ball and butterfly. Valve positioner, which ensure the valve has reached desired degree of opening to overcome the problem of friction and wear. And valve body, which molding element, a plug, globe, ball or butterfly is contained. Control axis. Now, evaluation analog of the control loop signaling from the pneumatic area to the electronic area. Example current loop use sensing and control transmission. The specific example smart valve positioner, control globe valve, pneumatic diaphragm actuator and smart positioner also feedback the controller and actual valve position. Now air to current to open, the flow restriction decrease with increased signal value. Air to current close, the flow restriction increases with the increased current signal value. Air or control signal failure on failure compressed air to the actuator, the valve close under spring pressure or by backup power. Air or control signal failure to open on failure compressed air to actuator or valve open under spring pressure by backup power. The mode of failure operations required failure safety process control specification of the plant in case cooling water it may fail open, in case delivering chemical it may be fail to close. Valve positioner, the fundamental function of the positioner deliver pressurized air and valve actuator set the position of the valve stem and shaft correspond to the set point the control system. The positioner are typically used when valve require throttling action. A positioner require position feedback from the valve stem or shaft and deliver pneumatic pressure to actuator open and close the valve. The positioner must mount it near the control valve assembly. There are three main category positioner depending on type of control signal and the diagnostic capability, the communication protocol, pneumatic, analog and digital. Now, pneumatic positioner. processing unit pneumatic pressure signaling the control point to the control valve. Pressure typically molded between 20.7 and 103 kPa, 3 to 15 psig. Move valve from 0 to 100% position. It is common pneumatic positioner, a position of the valve stem and shaft is compared the position of bellow that receive pneumatic control signal. When input signal increases, bellow expand and move a beam. The beam pivot about the input axis that move flapper and closer the nozzle. The nozzle pressure increases, which increases output pressure. The actuator, pneumatic amplifier relay, increase output pressure. The actuator causes the valve stem to move. Stem movement is feedback and beam by means of cam. As cam rotates, the beam pivot about the feedback axis to move flapper slightly away from the nozzle. Nozzle pressure decrease and reduce output pressure to the actuator. Steam movement continue backing the flapper away from the nozzle until equilibrium is reached. When input signal decrease, bellow contract and the beam pivot about the input axis to move flapper away from the nozzle. Nozzle decrease and relay permit the release diaphragm casing pressure to the atmosphere, which allow the actuator stem move upward. All through the steam movement, feedback, the beam redeposition flapper closer nozzle. When equilibrium condition obtained, the stem movement stop and flapper is positioned, prevent any further decrease actuator pressure. Now, the second type positioner, analog, input pressure positioner, means modern processing unit, signal to modulate control valve. This introduce electronic into positioner design. The required positioner convert the electronic current signal to pneumatic pressure signal, current to pneumatic or typical I/P positioner. The converter receive a DC input signal and provide proportional pneumatic output signal, nozzle/flapper arrangement. The pneumatic output signal provide input signal to the pneumatic positioner. Otherwise, design is same to pneumatic positioner. Digital positioner. When pneumatic positioner and integrate and process positioner provide the basic valve position control, the digital valve controller. Another dimension, the positioner capability, type of positioner, microprocessor based instrument. The microprocessor are the enable diagnostic two-way communication, simplify setup and troubleshooting. Typical digital valve controller control the signal ready to the microprocessor, process digital algorithm, they converted drive current signal converter. The microprocessor perform the position control algorithm rather than mechanical beam. Cam flapper assembly as control signal increases the input positioner converter increases output pressure of the input converter. The pressure is routed. The pneumatic amplifier relay provide output pressure to actuator, which increases control signal. Output pressure always increase and other output pressure decrease. Double acting actuator output, where single acting actuator only one output. Changing output pressure causes actuator stem and shaft to move. Valve position, feedback microprocessor. Stem continue, move until correct position. At the point, microprocessor stabilize, drive signal, input, converter until equilibrium is obtained. Now, in addition, function controlling position valve, digital valve controller, have additional capability, diagnostic, two-way digital communication. Now, advantage, placing a smart positioner control valve are automatic calibration and configuration positioner, real-time diagnostic, reduce cost of the loop commissioning, include installation and calibration, use diagnostic, maintain loop performance level, and improve process control accuracy that reduces process variability. Now, type of control valve. Based on pressure drop device. High recovery valve. The valve typically regains most of the static pressure drop inlet vena contracta outlet. They are characterized by the lower recovery coefficient. Example: butterfly valve, ball valve, plug valve, and gate valve. Low recovery valve. The valve typically regains little static pressure drop. Inlet, the vena contracta outlet. They are characterized by the higher recovery coefficient. Example: globe valve and angle valve. Now, based on movement profile controlling element, they are sliding stem, the valve stem and plug move linear or straight line motion. Example: globe valve, angle valve, wedge type gate valve. Rotary valve, the valve disc rotate, butterfly valve and ball valve. Based on functionality, control valve. Control parameter, proportional, input signal, receive the central control system, globe valve, angle valve, ball valve. Shut off and on off valve. The valve are either completely open or closed. Gate valve, ball valve, globe valve, angle valve, pitch valve and diaphragm valve. Check valve, allow flow only single direction. Steam condition valve, regulate pressure and temperature inlet media, required parameter outlet. Example: turbine, bypass valve, process steam, let down station. Spring loaded safety valve, close force of the spring which retract open when inlet pressure equal the spring force. Based on actuating medium, manual valve actuated by hand wheel, pneumatic valve actuated using compressible medium like air, hydrocarbon, nitrogen, spring diaphragm, piston cylinder and piston spring type actuator. Hydraulic valve actuated non-compressible medium, water and oil, and electric valve on electric motor. Wide variety valve type, control operation. However, there are two main form of action: sliding stem and rotary. Now, common versatile type control valve, sliding stem, globe, V-notch, ball, butterfly, angle type. The popularity derived drug construction and many options available. The suitable variety, process application, control valve, body may categorize as sliding stem, globe valve, flow control device, angle body valve, angle set position valve, axial flow valve, rotary, butterfly valve, flow control device, and ball valve. They are flow control device. Other: pitch valve, valve close, squeezing a tube, and diaphragm valve, flow control device. Okay guys, this is up to today's topic, control valve. I hope you get sufficient knowledge after watching this video. Next step we have covered next Sunday some another chemical engineering topics. Till then, goodbye. Do take good care of yourself.